Welcome csc121 to our Python function review. This information is directly from the How to Think Like a Computer Scientist Interactive Edition book from Chapter 6 that reviews functions. And I encourage you to read through that and go over the definitions and the terminology related to functions and the structure of a function. And the purpose of this presentation is just to go over flow of execution and just understand what's happening within a function in even very simple functions, just to help you debug, to help you troubleshoot, and to help you write your functions better. So let's look at the first example. And this is right out of the book, and it's a very simple function. And we're going to look at a little bit of the terminology here. We basically have a function definition, the keyword def, the name square, which can't be anything that's a Python keyword. It's a name you give it, and you might want to keep it lowercase and keep it as simple as possible and make sure the name is something that it actually does, which it does. It's going to square a number. And then also in the parentheses right next to it, what we have is an X that's standing for, or that represents a parameter. It means there's going to be a number that's going to be used when the function is called. So in our function definition, we have our body of our function, which is indented, and we have a little formula here that has y equals x times x. And then there's actually a local variable declared here, which actually, because we're getting x, it's actually reassigning x to be 0. And then we're getting a return value, which is going to be the y from this formula that's up here. So this will really, actually, when we go through it, you'll see it won't really have a purpose. And then down here at line 6, is a global variable, which is declaring x to be equal to 2, and that's actually going to be the number that we're going to be sending as the argument, which will be passed back up to the function when it runs. So this is the function call down here at number 7, and it actually has a variable that represents the function call, which is fine because it actually makes the print statement simpler, because you don't have to put square x or whatever in the print statement. You could just put z in there, and you'll find that using variables to represent either the function call or the arguments that are going to be used to pass with the function call will kind of make things easier, especially if you're going to print out some kind of expression or statement at the end. So let's just look at the flow of execution here. We have at line 1, we have the function definition, and then it's going to kind of bypass the rest and jump here to x equals 2. So it's going to say, okay, x equals 2, and then it's going to say, okay, z is the function call, and it's going to run the function square with x. Do we have x? Yes, and x is actually 2, so this is going to go into there. So that's actually using a global variable is going to be used to represent the argument. You could just as easy put 2 right in here, but that we're kind of taking an extra step and saying that's going to be 2, and we're going to put it in there. And then what's going to happen, it's going to go back up to line 1, and it's going to start going through the function, and it's going to use 2. And it's going to say, okay, y equals 2 times 2, which is 4. And then it's going to come down to the line 3 and say x equals 0, which really has no purpose. So this is just kind of an example of showing what not to do. There's no reason to really have x equals 0. It's actually reassigning x to be 0, which doesn't really serve any purpose because it's happening after the formula is run anyway. And then we're returning y, which is going to be 4. And then it's going to go back to 7, and it's going to say, okay, we just ran the function, and for z, after running the function, it's going to be 4. And then 8 is going to print out z, which is 4. So it's going to print out 4. So we have a global variable, which is fine because it's getting used as the argument. And then up here, it's actually being used through the formula. So sometimes you might actually want to use like n equals 2 and put an n in here. These aren't always going to be the same. Usually they're different. Usually the argument, which is down here, is going to be different from what you originally set up to be the parameter. And again, this is the actual parameter. The name out of the chapter, they say it's also known as the actual parameter. We're going to use the term arguments. Up here, they call this the formal parameter, but we'll just call it the parameters. But usually these are different. So, we don't want to be getting confused because we have a local variable, we have a global variable, we have an argument, and we have a parameter that are all x, and it makes it a little more confusing. So you'd be better off calling this n equals 2 and putting n in here, and then when it runs the function, it's just applying n as whatever number you're putting in there, 2, and then running it through. And this x equals 0 really has no purpose in there. So let's look at the second one here. Here's another example, and again, this is an example of what not to do, even more so. And here's the function definition. It's power of, so you get what's happening here. It's doing a power of, and you're basically going to supply a number and a power. And they have power equals p, which again, it says another dumb mistake. There's no reason to really use this. And then it just basically says, okay, take the number to that power. This is another way to make a power with x with the two asterisks. We'll actually put it to that particular power and you'll get a return. Now down here they did the same thing. They had power equals 3, but they're not putting it anywhere. I mean, there's no real purpose of number 6 at all. Line number 6 has no real purpose here because we're not using it because we already have actual parameters or arguments that are here. So we're sending arguments anyway. So this has no purpose at all. I don't know why they're doing that. You might, if anything, you'd be better off having a variable that said power equals 2 and n equals 10 because that's actually what's going here. This is the number and this is the power. So this really has no purpose. So this is just showing something that's not written very well, but you know, it's good to kind of explore it anyway. So let's look at the flow of execution. Power of x and p. So then we go down here, power equals 3 means nothing, so skip it. And then result is the variable that represents the function power of. And then we're going to call the function and use these arguments 10 and 2. So we'll run up here and put in 10 and 2. And then we'll come here and say power equals p. Well, p already is 2, so it's just going to say power. That just means power is 2. So it's just kind of swapping out p for power is all that really does. That's why it says it's a dumb mistake. It's not a mistake. It's just unnecessary. You know, if you're going to use the word power, then just put PWR or something, and then you could use it here, and then you wouldn't even need this line. There's no need to be rewriting a bigger variable name in the middle of this. You know, since you're already using p, if you want it to be more readable, then just put PWR or something like that. So this is not necessary at all. But it'll still work. It'll still say y equals x to that power, and it'll still return a number. So it's still going to return 10. Because that's the number we're using, and then this number is going to be 2, so it's going to return 100, and then it's going to run down here after it returns y. It's going to say, okay, our result that we got is y. From this function call, our result is y, and let's print out the result, which is going to be 100. So that works, but it has some things that you don't need. This, not needed. Power equals p, not needed. And let's look at another one. This is one that's actually do an accumulator function, and this is kind of done a little bit better because here's our function definition, and then we'll move down here to our global variable, which is 2 square, and the purpose of this, it's just setting a number that can be used as the argument. Again, you could just as easy put 10 in here because that's the number you're going to use, but we're kind of setting it up ahead of time. And the purpose of that too, if you just look a little further, is that they're going to use 2 square in this print statement, which makes it a little easier to put a variable in a print statement rather than trying to put a number in there and convert it to a string and all that. You know, that could be a problem sometime, especially if you're concatenating with plus signs or however you're doing it. But that just makes things a little bit easier, and for the same reason, it also makes the call function easier. So whatever result they get is going to be a variable, and then they're actually going to use that in this print statement as well. So that's actually going to work fine at the end. So basically, if we look at our flow of execution, here's the definition at 1. It'll jump down to 8. It'll put 10 in here. And then once it has 10, it'll go back up here again. It'll supply 10 in here. And then this one actually says this is doing a count. This is like an old-fashioned way of doing kind of a square. It's actually kind of add 10 up 10 times. And that's kind of what it does. It basically puts 10 in here, and it runs it 10 times and adds itself 10 times. And the running total will count it. Will count the number. The number will build up. So basically, if you look at it this way, okay, the first time it goes through, it says running total 0 equals 0 plus x, which is 10. So the first time through, it'll be 10. And then it'll go through a second time. The second time, it'll start with the running total being 10, and then it'll say running total equals itself plus 10, which will be 20. And then it'll just keep building up from there and up to 30 and up to 40 and up to 50 and up to 60 and finally up to 100, and then it's going to return 100. And, you know, again, that's kind of a roundabout way of doing it, but it'll work. And once it returns that running total, that's what it'll get here from the result, and it'll put that result 100 in here as the variable, and then we could still use the square as 10s. The final print statement will say the result of 10 squared is 100. So let's look at another one. Here's another one just to look at flow of execution, and this says generalization. This is an example of generalization. There's two functions defined. There's pow and there's square. And what's going to happen here is one is really a child of a parent. The parent is pow because it does basically, it puts number to a power, any number to any power, and returns a value. Square is more specific because it only takes a number to the second power. And actually, instead of redoing the function by using these things, this one actually just uses the pow function. So it uses the parent function inside itself to make things easier. So that's how this is kind of a child, because it's based on the parent. So if we go through flow of execution, let's just look through it. The flow of execution is going to start here, function definition to 1, and then it's going to go down to 5, because it's not going to do anything yet. It's just going to say, okay, function definition. It'll see that n equals 5. It'll go down here. There's a variable being assigned to result, and that's the function call of square with 5. So then it'll jump up to 5 and say, okay, we're going to square 5. And then it'll go down to 6, and it'll say, okay, a is going to be set to running the power of 5 and 2. And now it's actually calling another function, so it's going to have to run back up here and say, okay, let's use 5 and 2, and then go down to line 2 and run the formula, which is going to be 5 to the second power, which is 25. And then it's going to return 25. And then it's going to come back down to 6 and say, okay, we got the number. It's 25. Let's return 25 at 7. And then it'll come back down to 10 again and say, okay, the result is going to be 25. And then we're going to print the result at line 11, which is just going to print out 25. So that's the flow of execution. And here it is in order, 1, 5. And that's what we kind of did. We said it goes from 1 to 5, down to 9, down to 10. 10 sends it back up to 5 because that's the function call. It goes back up to here. It goes back up to 6. And then 6 sends it back up to 1 again. And then it runs through here and it goes back to 3. And then it goes back to 6 because now it has a value. And then it goes to 7. And then it goes to 10 and 11. So that's actually the flow of execution. And it's good to follow that, and it's good to know that, because it'll help you debug your functions and your programs, and help you, when you see an error and you don't know where it's coming from, knowing what's happening is helpful. And it'll also help you the way you write your functions, because you won't be putting in extra variables and extra parameters that you're not going to use. I mean, it takes time to kind of understand that process and what works best and what is more efficient, but understanding these simple little flow of executions are helpful. This last one basically is another example of generalization like we just saw, because it really has a function that's a child function. Draw square is a child function of draw rectangle, because a square is a rectangle. So they already have a rectangle function which goes through and takes a width and height. This is using turtles. It takes a width and height, 2 values, whereas when you draw a square, you'd only need 1 value for size. So what they do is they have a draw square function, and it basically uses draw rectangle, and whatever size you put in, it just puts it twice so that there's the correct number of parameters to use up here when you actually run the function. So it just puts the same number in here for the width, same number for forward 2 times instead of using width and height, because the function they're actually calling here at line 19 is actually draw square. So they're calling draw square, it's going here, and it's going to say, okay, here's 2 numbers, and let's use these numbers with the draw rectangle function, and let's just use our second number twice, because that's really what a square is. And we'll just reuse this function because it's already set up. So why duplicate the function when you don't need to, when this one already can do what a square function can do? So that's generalization. So these are just a couple simple concepts to help you hopefully understand the flow of your code and the flow of functions a little better, so that when you run into problems, you run into errors other than syntax errors and things like that, you understand where there's a breakdown somewhere along the line. And by understanding that, it'll help you write better functions too, I think, and also write functions that are kind of more concise, more efficient, and that work a little bit better. Hopefully that's helping you out a little bit. And again, make sure you check out, like I said, this is chapter 6 of the How to Think Like a Computer Scientist Interactive Edition. Go through there. They have Code Lens in there, which helps you actually see the flow of execution a little bit better. And check that out, and check out the definitions as well.